Okay, so we got the region formed by y equals 0, y equals x squared, and x equals 8. We got the line y equals 70, and we're trying to imagine what that thing will look like when you rotate about y equals 70. So if we draw the mirror image, that would be like when this thing is halfway around, right? Halfway around. So it'd be something like this. Imagine this, right? And then okay. So imagining that thing going all the way around 360 degrees, every point in space that that region touches will be our solid. Do you have a visual of that solid? Can you see what that is? I'll try to draw it. How would you describe it? Yeah, it's like a bowlish thing with a hole in the bottom, right? It's gonna have that hole, and then there's gonna be like this. So it's kind of like it's a bowl with vertical sides, but up on its side, and then if you tried to fill it, the water would there'd be a big hole in the bottom, right? Okay, so what are we gonna do here? We're gonna start with our typical strip, and we'll do that right here like this. And we're gonna imagine what does the typical strip result in when we rotate around y equals 70. So we take that typical strip, we're going to go around y equals 70. What are we going to get? Is it a pancake? Well, kind of, but it's like a pancake with a big hole in it, right? It's going to be like a pancake with, let me draw it over here. So I'll draw a second typical strip over here. A little more mass to it, okay? So when you imagine that strip going around y equals 70, it's going to be flat and round like a pancake, but what's the difference? It's going to have a big hole, right? It's going to have a big hole, so we're going to get something like this. Still going to be a pancake like this, but then there's going to be a hole in it. And flat. It's like a, it's not. Yeah, yeah. Okay, so we're going to just approach the same way we did before, but now our typical element is a little bit different than a pancake, right? So we're going to say, and we're going to, this is what we call a washer. So like you put a bolt or a screw through it, it's a washer, okay? And it gives you more of a surface to push against. So we're going to call this a typical washer. And so what's the volume of a typical washer? How are we going to get the volume of that? Yeah, so we've got a pancake, with a smaller pancake missing, right? So it's really one pancake with a smaller pancake in the middle missing. So we're going to do what? Pi r squared h, but we have two different radii here. We have like an outer radius, so it's called r naught, and then we're going to subtract the pancake we get for the inner radius. And that will always be the formula for a washer. If you have a washer, it will always be the big pancake minus the little one that's missing in the middle. It will always be pi r outer squared h minus pi r inner squared h. Okay, so now we go back to our picture and we say, what is the outer radius? Okay, so we're looking back here. Our outer radius is where? So this is the center of our strip right here. So the outer radius is going to be from the center of the washer all the way out to the edge of the washer. So that right there is R0. And is that a x coordinate, y coordinate, change in x, or change in y? Our outer. That's a y coordinate. Why? Because it starts at the x-axis. It's the y coordinate. And so what is that y coordinate for all the pancakes? It's the same, right? So do you see that the outer radius is the same for every typical pancake from the line y equals 70 all the way to the x-axis? So it's going to be just 70. Or we could start with y. So let's do y squared. But that y coordinate for every single washer is 70. Do you see that? Every single typical washer, all the way from the beginning to the end, has that outer radius, has this as the outside point, and this as the inner, the center of rotation. Therefore, the outer radius is always 70. Okay, now the other one. So now the inner radius, I'll do that in blue. So the inner radius is what? It's from that center of rotation to here. X, Y, change in X or change in Y? Change in Y. So we've got Y2 is here, and then Y1 is here. And so then that is our inner radius right there. So Y2 minus Y1. And what is Y2? Okay, that Y2, again, is that same 70 again. What is Y1? Y1 is the y coordinate of the curve, right? Do you see that? This Y1 is from here down to here. So it's the y coordinate of, sorry, yeah, right. So it's going to be, Y1 is just going to be x squared, right? Oh, and what is our h in all cases here? The height of the washer is this small dimension here, delta x. We should have done that first, right? We should have done that height first, delta x. And so then we know we need to get the radius always in terms of these radii in terms of x. Okay, questions on setting that up? Volume of the typical washer. Why? The radius is the hard part, right? Those two radii, that's the hard part. Questions on that? Do you see it? Okay, so now we're ready to write the volume of the whole thing. All right, it's going to be from. So now we're stacking them this way. So we go from, it's del dx, so it's going to be left to right. Where's the very first one? X equals 0. That's the one that's all whole and no mass, right? It's just all whole and no mass. And then the last one, 8, that has the most mass and the smallest hole. And then we've got our typical washer, so we just write it down. And we can factor out the delta x. So pi 70 squared minus pi times 70 minus x squared, and that all dx. It'd be, yeah, 2, yeah. Okay, ask if I lost you. Did you, so you need that formula for a washer, first of all. It's going to be outer pancake volume minus inner pancake volume, and then finding those radii is kind of the trickiest part. Questions? Okay, so now we're getting into some problems where the typical element is now paying dividends, right? Setting up this, just focusing on the one washer and setting up, just focusing on that and getting that right is kind of becoming essential. It's going to be hard just to skip right to writing down the integral. Okay. Can I erase? Let's see how it goes. So sketch this. Again, would be fair game, no calculator on the test, so you can sketch this region. So it says in the first quadrant, we're gonna get rid of that. With the whole region, not just the first quadrant. And so then the x-axis is no longer there. Oh wait, right? Sure. Good. We're just sketching the region right now. See how this goes. Before we start, let's just go ahead and find these points of intersection so we don't have to worry about them later. So we're looking for what? We could do values of y where the x's are equal, right? Values of that'd be easier here. So x is 6 minus y, and x is y squared. So if we set those x's equal, 6 minus y equals, or y squared equals 6 minus y. Let's do it that way. So we get y squared plus y minus 6. Y's are plus 3 minus 2. 2, and negative 3. So this point is 4, 2, right? Because x is y squared. So if y is 2, x is squared, so 4, 2. And this point is 9, negative 3. Okay, and then we're going to do about the line y equals, x equals 9. So that's the x, we know that's the x coordinate at this point. So here's 9. So we're going to rotate about x equals 9. Can you imagine what will you get when you do that? What will you get when you rotate? Yeah, that's pretty good. So it's like an oval shaped solid with a cone cut out of it, right? So the again, imagine, sketch what you'd get when it's halfway around. Not supposed to be straight. Yeah. So then what will this thing look like? It'll look like this. So this would hold water, right? So this is like a vase, like a rounded vase with a conical inside that would hold water. Okay, so we want to do, it's telling us to use strips parallel to the x-axis. Okay, so typical strip will look like this. And so then we imagine that being rotated around the line x equals 9, and we're going to get this. So we're going to get washers, but this time those washers are horizontal, the way that you could set a washer on a table. Okay, so a typical washer is going to look like this. Again. So you see how those washers fit into the solid. Okay. The lowest one is going to be just like a point washer, right? No mass and no hole. And then as it gets bigger, well, we're going to lose mass, and we're going to have the hole with the greatest radius at the top. Okay, so volume of typical washer is going to be our outer pancake volume minus our inner pancake volume. Okay, so let's get those radii, and then I'll let you set up the integral. So the outer radius is from here. This is the hard part. Don't tune out. From there to there, that's the outer radius. Do you see it? X, Y, change in X or change in Y? Change in X. Change in X. Okay, so what is it? It's going to be 9 minus the X coordinate of this. So we can just start by writing 9 minus x, right? 9 minus x, and then delta y. And then the other one is also, do it in blue. Here's the inner radius. Inner radius is from there to there. X, y, change in x or change in y? Change in x. Again. So it's going to be 9 minus x. That's squared. It's just there are different x's, right? For the outer radius, what x are we talking about for this x? Y squared, right? The x for the curve. So this will be y squared. And then for this one, the x is the x for the line, which is? Six minus y, right? So 9 minus quantity, 6 minus y. And then that whole radius squared. So yeah, 9 minus x, which is x equals 6 minus y. So the rest is just setting up the integral, and we're going to go what? Now y. So the lowest one is going to be at y equals -3 up to +2. Okay, so 2 web work sets are due Wednesday. Pancakes and washers will be put up today.